Hi, my name is Doug Summerlin, and in this video, I'll show you how I made a QR code scanner using only a Raspberry Pi with a camera module and the OpenCV library in Python. I hope you enjoy, and let's get to it.
Here we have the QR code o1.py program written in the lecture series. We first open the video feed with the cv2.video capture program. We then define the detector from the cv2 QR code library. With the while true loop, we create an infinite loop where we take an image from the video feed and run it through the detection algorithm to identify a possible QR code. If this QR code is detected, we create a bounding box around it, interpret the code as data, draw the bounding box around the code on the video feed, print the text on the video feed, and finally print the data to the terminal. This will continue until we break out of the loop by pressing the Q key.
So this is my Raspberry Pi with the camera module set up. And this is my headless setup that's interfacing with the Raspberry Pi. So here we're going to run the QR code o1 program. And as expected, we have a video feed pop up. And we can center that. And that's recording a video, well, not recording, but streaming a video from this camera module. So to test the QR code program, we'll write hello there, generate the QR code, and that's great. Now we have a QR code. And the idea is if I point that at the Raspberry Pi camera module and back it up a little bit, we have the data popping up on the screen, and the bounding box is also forming around the QR code with the hello there popping up. And that looks like 100% functionality to me, especially if I can close out of the program by pressing Q. Awesome, looks great.
So for my creative project, I decided to adapt the QR code that we wrote in class and create a tic-tac-toe game. And to do this, I found some code online that created a tic-tac-toe board with a series of print statements and defined the different squares of the board with an array from 0 to 8 for 9 total squares. I added some print statements of my own to define how the game's played. And as far as acceptable QR code inputs go, it is an X or an O followed by the grid number to mark the square. For example, X3, 06, or X8. To implement this functionality, I went into the data section of the loop, and I said for I in range of the length of the board from 0 to 8, if the QR code reads like an X0 or like an 07 or something like that, we'll take the 7 or the 8 for that range in the for loop, and we'll create a string from it. And then we'll say if that data is matching that string that we detected, then we'll go to that ith value of that array and put an X or an O there, and then print that X is moved or O is moved. And that functionality is pretty much the same.
A QR code tic-tac-toe program to demonstrate its functionality. So it works similarly to the regular program, except for when we run the program, the video feed pops up on the Raspberry Pi and we print the tic-tac-toe board in the terminal, accompanied by a few messages. It says, welcome to the QR code tic-tac-toe. This board is laid out like this. Enter X or O followed by the grid number to mark square. So I took my little brother's phone to generate a QR code. We're going to generate X5. And we'll zoom in on that and present that to the video feed. And once it gets a detection, you can see that it prints X has moved, O's turn, and the 5 in the grid is replaced by an X. So to prove its robustness, we'll create a new code. We'll make this one 0, not O, 0. So we'll do 0. And why not 0? So we'll generate that code. And then zoom in on that. Present that to the video feed. And then once it gets a detection, it says that O has moved and it's X's turn. And if you go further, if you go in the early in the video, this was actually a 0, and we replaced it with an O, and you can tell because there was a dot in the middle for the 0. So yeah, that's how I got creative with this project.